Hello, in this video we are going to see different types of transmission line structures. We can see these type of transmission line structures literally everywhere. So in older days, if you want to connect the antenna to the TV, we use tin lead wires, and if we have to connect the ICs to the antennas in a PCB, we will be using these type of microstrip line structures or strip line structures. So they are of different types. They are suited to different frequency ranges, power levels, and applications. So let's see what are they. So the first type is wire-based lines, which consist of coaxial cable, two-wire lines, twisted pairs. So the coaxial cable is the most common type. It has the inner conductor and outer conductor separated by the dielectric. As it is surrounded by these external conductor, it offers excellent shielding and it provides low radiation losses. And it can also work from DC to up to 10 gigahertz of frequency. Sorry. In case of the twin lead wires, it consists of two parallel conductors separated by some distances. So it is mainly used in older TV applications like connecting the Yagi Uda antennas to the TVs. Because of this structure, it will be radiating significantly and it is sensitive to nearby object. In case of the twisted pairs, it consists of two cables which is twisted together to cancel the electromagnetic interferences. Planar or printed lines. So these will be consisting of mainly planar structures, and they are classified into microstrip, stripline, and coplanar waveguide. So in case of the microstrip, it has the uh, two conductors. First one is the feed. So this is the feed and this is the ground, which is separated by the dielectric. So this is one of the most commonly used in PCB application, and it is very easy to fabricate and design. But the main problem with this is it will cause some radiation, because you can see that it can cause some radiation problems if we are using these type of microstrip feed lines. In case of the strip line, the feed line is embedded inside the dielectric and we have the ground plane on top and bottom. So because of this structure, it will be having low radiation loss. But it is very hard to access for the components as this feed is embedded in the dielectric. In case of the coplanar waveguide, it has the feed line and the ground on the same surface. So this middle one is the feed line and these are the ground. So these are on the same line, and sometimes there will be one more ground plane below the dielectric. Sometimes this will not be there. So the CPW are of two types. Sometimes it will be like grounded CPW, or sometimes it is ungrounded CPW without this extra ground plane. And next one is hollow metallic structures. So this will be consisting of rectangular waveguide, circular waveguide, and ridge waveguide. So in case of the rectangular waveguide, the cross sections shows the rectangular structure, and circular waveguide, the cross section shows the circular structure. So in case of the rectangular waveguide, the transmission mode is not TEM, it is like TE and TM mode, and there will be some cutoff frequency for this. So that is similar for the circular waveguide also. As it is like surrounded by these metallic structures, it has low radiation losses and good power handling capabilities. One more thing is ridge waveguide. Here you can see that some ridge type structures on the broad side of the rectangular waveguide. These type of ridges will extend the bandwidth and they will lower the cutoff frequency. That is the advantage of using these ridge structures. So I hope you get some idea about what are the common transmission lines. Thank you.